All right, friends. So let's look at a problem uh, which is basically involving some math and some understanding here. So this problem is basically given set of two-dimensional area, like so, sort of like a histogram or buildings. Um, how would you determine what is the largest solid area formed by the consecutive so-called rectangles, right? So to illustrate the problem, so uh, we have uh, a building. Let's say each building is unit size, right? So the width of the building is just one, right? So 1 inches, 1 centimeter, whatever. So we'll just think of it as one, right? And but different heights though. So let's say we have a building of height 8, right? And then we have a building of let's say height 4, and then let's say we have a building of uh, height say 6, right? And then we have let's say something like 5, right? So we have 5, and then let's take two more, so to make the example a little more concrete here. So so this is adjacent building, so 7, and let's pick one which is really small, x 3, right? So the question says that what is the largest solid rectangle that can be formed using these consecutive buildings, right? So if we were to index them, these were 0, 1, 2, 3, 4, and 5. So we have total 6 buildings, right? So if you think about it just for a moment, um, let's say you're considering this building, right? So this building right now, the only rectangle that you can form, right? So the rectangle that you can form with this building, right, is just this area, right? So this particular area. So what would be the area of this particular first block, right? So that would be 8 times 1. One is the, remember, each one is unit width, right? So one is the width. So this is the width, and this is the height, right? So 8, right? 8 meter square, or whatever they want to call that. So if you look at the second one, right? So if you look at the second one, then if you were to make a, let's say, so this is, let's say that's not a straight line, but uh, so if you were to make a rectangle using this height, right? So using this height. So if you were cutting through the entire piece here, right? So what 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 is the max rectangle that you get out of this, right? So the buildings, so the only buildings that would contribute to rectangle for uh, this particular case, or this particular entity that we are referring to, are the ones that are going to be at least 4 or higher, right? So we can cut through and sort of make like a solid rectangle out of it, right? So if you look at 3 here, it's much smaller. So my rectangle just ends here. So if I were to shade this region, so this entire region would form a solid rectangle, right? So what would be the area of this part, right? So the area would be uh, so 1, 2, 3, 4, 5, right? So there are uh, 5 entities or 5 blocks here, or 5 different individual rectangles that are contributing to a larger rectangle, right? So which includes this rectangle itself, to this rectangle's solid area, right? So and each is unit, right? So each would be height 4, because that is limited by this particular rectangle block that we're looking at. So 4 times each is unit, and we counted 5, right? So 4 times 5 would be 20, right? So how did we get that? We went left, and we looked at all the rectangles that were bigger than the rectangle that we are considering, which is this particular rectangle, right? So this was bigger, this was bigger, this was bigger, this was bigger than 4, and So we counted all of these, right, including this. So so we went left and we went right and we counted all of those, right? So that would be like a naive approach. And similarly, if we look at 6, so and then we have to be careful. The bigger ones that we're looking at should be consecutive, right? So it has to be adjacent. You can't take 8 here and make a solid rectangle, because there will be a hole out here, right? So this guy will not contribute. So it has to be adjacent rectangles. And so if you look at 6 here, the adjacent rectangles to this are both smaller. So they're not extending this particular rectangle. What do we get here? So we get, for 6, we get 6 times 1, which is equal to 6. If you look at 5, so we go left first. So 6, yes, it contributes. It's definitely bigger than 5. And then 4 is not, right? So it's going to give us a hole here. So we get 1 here, and then if we go towards the right, then 7 is greater, so we get 1 more, and then 3 is smaller, so that's not going to contribute to 5. So including 5, we get 1, 2, and 3, right? So 5, if we were to uh, let me just undo the previous one so that we can look a little more carefully for 5. So that was 6. So if we were to look at just 5, so this solid region would give us 5, right? Uh, any rectangles that are bigger than 5 towards its left and right are going to give the solid region. So we counted 3, right? So that would be 5, and each is unit, so 5 times 3 is 15, right? And the same thing we do with 7. So 7 has both of them smaller, so 7 times 1, 7, and obviously 3 has no rectangles to its right, and all of the rectangles to its left are bigger, so we count 1, 2, 3, 4, 5, 6. So that would be 3 times 6, which is 18, right? And so the largest rectangle that we get is this 20, right? So a brute force way is to let's say you have like two for loops, and at every index you sort of go left and go right until you find the first rectangle that is smaller than the current one, right? So you go left and then you go right. So and then you find the first rectangle. So first rectangle uh, whose 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 height is is smaller whose height is smaller than than let's say the current rectangle, or I, right, which is the current rectangle, right? So that's the naive approach, and then you count them and then multiply it with the current height, and you get the sum, right? So what would be the time complexity of this approach? We have two for loops, and each of the for loop would go all the way left, all the way right. So in worst case, we'd end up having sort of like a n squared complexity, right? So but this gives us a nice intuition, right? So the stopping point of the the iteration is whenever we encounter a rectangle that is smaller than the current rectangle on each side, right? Uh, on on each side, right? Each left and right. And we look at the cases when there are no rectangles towards either the right or to the left, like we saw here, right? So, so let's look at a better approach in the next video.